Finney Smith has a mismatch. He's got Kressler. Shot clock winding down. Yeah, he'll go to
beauty.
We're talking about small changes. Just in.
The first thing we wanted to do is calculate the amount of force that the Vanderbilt player put on the ground when he jumped to block the shot. To use this, we did Sadler's equation, which is 60.7 times the jump height plus 45.3 times the body mass minus 2,055. For his jump height, we guessed that it was around 33 inches, and his body mass was given on team roster, which is 83.9 kilograms. We then multiplied 60.7 times the vertical plus 45.3 times the body mass, and got 2003.1 plus 3800.67 minus 2055, which equated to 3,748.77 newtons of force exerted on the ground when he jumped to block the shot.
It was good, all right.
The next thing we wanted to find was the velocity of the ball after the block and the force put on the ball when it was blocked. To find the velocity, we did velocity equals distance divided by time, in which we had found that the ball traveled 13 feet in a time of 0.6 seconds, giving us a velocity of 21.667 feet per second after the block. Next, we wanted to find the force that the player exerted on the ball when he blocked it. So we did force equals mass times acceleration, and the force equals 0.65, which is the mass of the ball, times the acceleration of 11 meters per second of the ball, to find a force of 7.15 newtons on the ball.
Next, we were able to find the distance based on the court dimensions and where he releases the ball to determine the overall shot distance. The opposite free throw line is about 70 feet from the basket, and we also subtracted Josh Henderson's shoe size, which he wears a size 16 based on the tweet we tweeted at him. We subtracted this and we got an overall distance of 68 feet 10 inches. Now, using the distance we just found, we divided by time, which was 1.8 seconds, to determine the overall horizontal velocity, which was 11.62 meters per second. Next, we were able to find the max height, which was 3.5 times the player, who was 6'1", who was standing below the shot, making the max height about 6.475 meters. We used the max height, which equals V naught squared sine squared theta divided by 2g. So then we ended up finding that the V naught equals 27.8 meters per second, and that our angle is 31 degrees.
So what we wanted to do next was find the energy of the basketball. To find our energy in the x direction, take the equation K equals 1/2 mv squared, plug in your data, get an answer of 42.1 joules. And then the next thing you're going to do for the y direction, take the tangent of angle theta, which is 31, which is equal to the velocity in the y direction divided by the velocity in the x direction. Once you solve for that one, you're going to get your velocity in the y direction equal to 6.15 meters per second. And then you can finally solve for the energy in the y direction, once again doing K equals 1/2 mv squared, but this time in the y direction, of course. Plug in your data, get an answer of 11.8 joules.
Now that you've learned all the physics behind this amazing shot, take a second look and see how impressive it really was.
We're talking about small changes. Just tiny things that change the outcome of games or moments. Let's go to Kaylee.